Hello, viewers and learners. Welcome to Figure Maths with Tirema. And today on mathematics, we have the following questions to solve. And before we dive in, as usual, what I have for us today is nobody builds himself by doing what is convenient. Nobody builds himself by doing what is convenient. So it's very important to understand that to somebody that says conveniency is the burial place for greatness. If you're gonna be great, if you're gonna do something extraordinary, it's gonna be inconvenient. So, but the inconvenience does not worth the profit, does not want the productivity, the success that we accompanies it. All right. Just like the scripture says that our light affliction, which is but for a moment, worketh for us a far more exceeding eternal weight of glory. All right. So it doesn't matter what you are facing right now as student or the challenges, the problem before you, you don't consider it. You consider the joy, the joy of the success, the joy of the outcomes that we accompany it. All right. So, so get that understood that nobody builds himself by doing what is convenient. Somebody that wants to build, that wants to have his body shaped to as desired, then he or she will enroll himself in gym. So in the gym center, you will discover that carrying the weights and doing all the exercises is not convenient. But then the person doesn't look at the inconveniency. He looks at what he wants to achieve. It's the same way as a student or learner, you look at what you want to achieve rather than considering the temporal circumstances that are not convenient. All right. So having said all of that, let's dive into what we have. I believe you have learned something from all of that already. Now, if 18 raised to the power 2 over 3 multiplied by 12 raised to the power 1 over 3 is equals to 2 to the power of n and 3 to the multiplied by 3 to the power of n. Find the value of n plus n. Now, this kind of question, uh, 18 is not a perfect square. So what you do is that you split it into factors, into its factors, such that perhaps one can be a perfect square while the other is not a perfect square, like that. So what you have is solution. Now 18, let's write down the question first. Multiply by 12 raised to the power 1 over 3 equals 2 raised to the power m multiplied by 3 raised to the power n. So 18 raised to the power 2 over 3 raised to the power 2 over 3 becomes, can also be written as 2 multiplied by 9 raised to the power 2 over 3. Then this one can also write it as 4 multiplied by 3 raised to the power 1 over 3 equals 2 raised to the power m multiplied by 3 raised to the power n. All right. I can further turn this to index form, this 9 to index form. So it becomes 2 multiplied by 3 raised to the power 2 into bracket 2 over 3 raised to the power 2 over 3 multiplied by, can also change this 4 to index form such that I'll be able to compare with the right hand side. So 2 raised to the power 2 multiplied by 3 raised to the power 1 over 3 equals 2 raised to the power n multiplied by 3 raised to the power n. Alright? So now I can expand. I can expand actually. I can expand with this power 2 over 3. 2 raised to the power 2 over 3. I expand what is inside the bracket with this power. I will likewise do the same thing here. So now this 2 is having the power of 1. Okay, 1 multiplied by 2 raised to the power 3 and 1 multiplied by 2 over 3. That will give you 2 raised to the power 2 over 3 multiplied by 2 multiplied by 2 over 3. Okay, so that's 4. It is 2 times 2, 4. Okay, it's like doing 2 times 2 over 3. It's 2 times 2, 4. Okay, so 4 divided by 3. Okay, multiply by, do the same thing here. This becomes 2 raised to the power 2 over 3 multiplied by power of 1 times 1 over 3. That's 3 raised to the power 1 over 3 equals 2 raised to the power n multiplied by 3 raised to the power n. Alright, so what you need to do here is collect like base. Collect like bases. So if you collect like bases. Collect like bases, that is the one that are equal, the bases that are equal. So you have 2 raised to power 2 over 3 multiplied by 2 raised to power 2 over 3 multiplied by 3 raised to power 4 over 3 multiplied by 3 raised to power 1 over 3 equals 2 raised to power m multiplied by 3 raised to power n. Alright, so all you need to do now is to apply the rule of indices, whereby since they have the same base, you will add the power together. Okay, if you add the power together, you're going to have 2 over 3 plus 2 over 3 multiplied by 3 raised to power 4 over 3 plus 1 over 3 equals 2 raised to power n multiplied by 3 raised to power n. Alright, so you have this. So since they have the same base, already you're supposed to find the SCM, but since they have the same denominator rather, so you just add the numerator together. That's the shortcut. You don't need to stress yourself. So 2 raised to power, that's going to be 2 plus 2, that's 4 over 3 divided by 3 multiplied by 3 raised to power. We do the same thing here. Add the numerator together, pick one of the base. So that's 5 over 3 equals 2 raised to power m multiplied by 3 raised to power n. So all you need to do right now is compare. Okay, just compare. All right. So just compare. When you compare, you're gonna have um, you're gonna have this compared to this. It means that the power here is the same thing as this power, and the power here is the same thing as this power. So what that means is m is equals to 4 over 3, and n equals 5 divided by 3. Meanwhile, um, the question says we should add n plus n. So which means m plus n. Therefore, n plus n equals 4 divided by 3 plus 5 divided by 3. Again, they have the same. They have the same denominator. So you add the power to in the numerator together. So that gives us 9. 4 plus 5, that's 9. Okay, 9 divided by 3. Let me just show it. 4 plus 5 divided by 3. That will give us 9 divided by 3. And your final answer will be 3. Alright, so that's the that's the answer to that. Now let's look at the second one. So when you see a question like this, um, you don't need to panic. All you need to do to bring down this mountain is to start from the base. You start from the one that is underneath. Okay, you solve it from simple to the complex. Okay, you know mathematics is always from simple to complex. Okay, so now you have this square root of 100 r raised to power 8. So if you simplify that one, square root of 100 r raised to power 8, okay, that's the solution. So the square root of 100 r raised to power 8 is the same thing as, we can rewrite this as 100 r raised to power 8 raised to power, this square root is also the same thing as raised to power 1 over 2. Alright, so we can change this 100 to index form. It becomes 10 raised to power 2. Okay, 10 times 10 will give you 100. Then r raised to power 8, all raised to power 1 over 2, raised to power 1 over 2. So this can become 10 raised to power 2 multiplied by 1 over 2, r raised to power 8 multiplied by 1 over 2. That will give us, that's 10, 2 cancel 2, that's 10. 2 here, 1, 2 in 8, that's 4. So r raised to power 4. Okay, so we have sorted this out like that. So that means it has now reduced to 160 r raised to power 2. Okay, there's addition here. So 160 r raised to power 2 plus square root of 71 r raised to power 4 plus 10 r raised to power 4. Okay, so the mountain is becoming valley gradually. All right, so now these have the same the same, the same, you have the same, this can be added right now, right? Now we can add this 71 r raised power 4 plus 10 r raised power 4. It becomes 160 r squared plus square root of 81 r raised power 4. Okay? Now, we can definitely find the square root of 81 to be 9. And the square root of r raised to power 4 will be r squared. Okay, you know, which if you have r raised to power 4 raised to power 1 over 2, just like what we did here, 2 here 1, 2 here 2. So this becomes 160 r squared plus square root of 81, that's 9. Square root of this is r squared. Okay, so then you add, becomes 160 plus 9, 169 r raised to power 2. Okay, so square root of 169, that's 13. That's 13. And square root of 1 square will give you r. So that's the final answer. So anytime you see any of these kind of questions, you can follow the same process and solve it. Okay, till we meet again, don't forget, nobody builds himself by doing what is convenient. So don't always look for convenience, also look for inconvenience, because that is what brings about extraordinary results. All right, so till we meet this time, bye. I remain Ayubusi to the bye bye.